I'd like to take a few minutes to show you some of the excellent graphing questions for polynomials and rational functions in MyLab. Many homework systems that I've worked with are just going to have multiple choice, especially for more complicated polynomials and rationals, but MyLab has some great tools available for you. Here we have the graph of a cubic, which has multiple parts, asking them to evaluate how is it rising and falling, what are the zeros, are these zeros where the graph passes through, or zeros where the graph turns around, of course repeated zeros. What is the y-intercept? After they answer all of these questions, finally they actually get to graph the polynomial. So if I click on this polynomial graphing tool, we click on the polynomial grapher, and now I have to select things like the x's and the y's that gave me this polynomial, and the y-intercept, and hit save and check. So just as the students would do if they were writing this on paper, they identify the x-intercepts, the y-intercept, where it's rising and falling, and then physically plot that out on the graph versus choosing something from multiple choice. MyLab also has many interactive figure questions. The question is presented, and then there's an interactive figure that the students will use to actually answer the question. This particular question asks students to set the degree to 6, and then click and drag the red zeros so that the 0 of 2 has a multiplicity of 2, -1 has a multiplicity of 3, and -3 has a multiplicity of 1. So let's take a look. We will set the degree to 6. 2 had a multiplicity of 2. -1 had a multiplicity of 3. And -3 had a multiplicity of 1. And then they're instructed to check the y-intercept box and adjust the leading coefficients so that the y-intercept is -18. Of course, the students could also calculate this algebraically, but in order to have a y-intercept of -18, the leading coefficient needs to be -1.5. While the students aren't actually graphing here, they're using the graph and manipulating the graph and creating the graph to evaluate and understand better what's going on. As you saw from the graphing tool in the first question, there was no rationals option. I'm going to go ahead and show this completed problem. When we're dealing with rationals, most likely it's going to be multiple choice for the graph itself, but several of these are set up and solve where they actually have to answer questions about what the shift is going to be up, down, left, or right for both of these, and then select the correct graph. One of the things I'm very excited to show you here in a minute is some new GeoGebra questions coming to many MyLab courses. But even with rationals, we also have interactive figures to work with. Here the question instructs the students to set a and c to 2, and then ask what value of b will result in a single hole in the graph. So here I have a and c set to 2. And now take a look at what happens to the curve as I adjust the b values. Very cool to see how it changes. And as I slide it around, I'm looking for a single dot, and I just saw one zip by there. So when b is equal to 3, then there is a hole. And why is that? We can discuss now, because the polynomial factors, and we have a removable discontinuity. So b equal 3 is correct there. And then finally factor the denominator based on our answer from part 1. Again, not actually graphing the rational, but working with it and manipulating it and seeing how the values of the function impact the information about the graph. Lastly, I'd like to share some really cool GeoGebra questions that are making their way to many MyLab courses. Here, students are given points from a polynomial function and asked to identify the polynomial function. So we have a 0 of -5, a 0 of -2, and a 0 of 5. The product of the constants will be -50, but our x-intercept is -3, which means we need a fraction of 3 over 50. It's a very cool dynamic question that the students are answering based on the points of the graph. Here the students are asked to place the dots on this graph that represent this polynomial. So we have a -4, -3, +5, doesn't matter where I grab the dots from, -1, and 2. For our final dot, the product of these comes out to 120 and then divided by -60. So that will give us a y-intercept of -2. So in the previous question, students were given the points and expected to find the polynomial. Here we're given the polynomial and expected to find the key points on the curve. The last couple of questions here have to do with rational functions. Students have to identify the asymptotes that they would need in order to graph this function. We have an asymptote at x equals 5, another one at x equals -1, and then as x gets large, this value goes to 0. Of course, that's the first step for graphing any type of rational function, is identifying its asymptotes and then looking at the limits at n behaviors. For the last question I'd like to share, students are given the graph of the rational function, and then they have to come up with the function formula. Here we have zeros of 1 and -1, and vertical asymptotes of 2 and -2. As x goes to infinity, the values are 1. This looks good. And just for demonstration's sake, I'm going to hit try another. This particular question regenerates questions that have 4 pieces, multiple things going on, and even oblique asymptotes. I hope you're as excited as I am to use these many different graphing question types in your MyLab courses.